Okay, in this video we're going to be looking at volume of rectangular prisms. Okay, so before we discuss finding the volume of rectangular prisms, let's take a look at the three different measurements that we've seen in the past and just kind of distinguish between the three of them. Okay, so the first one is length. When we want to measure the distance between 2 points, from here to here, this distance could be measured, let's say, in meters. Now there's different units it could be measured in, but we'll use meters for this one. So I could measure just the length of that, and maybe that's 5 meters long, right? So it's just between 2 points. Now that's different than measuring the area of something. Now the area of something is like how many squares would fit on the floor in a room. Let's say you're putting tiles down in a room and you want to know how many tiles you need to cover the entire floor. Well, that's not a measurement of just one dimension. You can't just measure length here. You've got to also measure the width to know how many to fit on. And so we use a single unit by doing the length times the width. Not just the length and not just the width, but the length times the width will give us how many squares we're going to be using. How many squares will fit on here. And we call these square units. Each one of these squares is a square unit. So in this case, I've got 4 in this direction and 4 in this direction, so it would be 16 squares total. And we write it like this, not like just meters, which is distance, but meters with a little 2 here, a little exponent, which means squared or square meters. Okay. Now when it comes to volume, we're now dealing with a 3-dimensional shape. We're looking at how much space is in a certain area. Not just the floor, but the entire room, like how much air is in the room, right? That's got to be measured in a different unit, because it's not just a flat thing like the floor, it's 3D, right? So in this case, this big Rubik's Cube here, how many cubes make up this Rubik's Cube, right? So I've got 3 in this direction and 3 in that direction. So on the bottom, I've got 3 times 3, so that's 9. I've got 9 cubes on the bottom row. But then I've got 3 of those rows stacked up, right? So 9 and 9 and 9. So 9 times 3. So there's 27 cubes here. 27 of these cubic units is the volume of this Rubik's Cube, right? And we measure that with a little 3 here. We write it not just meters, which is length, and not just squares, which is flat, but 3D. That's why I put a little 3 there. So cubic units, how many cubes would fit inside this box, would make up this box. So that's the difference between length, area, and volume. So if we take a closer look at this Rubik's Cube here. So the formula for this is to multiply the volume equals the length times the width times the height. So you're going to multiply the 3 dimensions together. Now kids have a hard time finding the 3 dimensions, so the easiest way to do this that I've found is to pick a vertex, which is one of the points, and to look at the 3 lines that go away from it, because any point on this cube is going to have 3 lines going away from it, and it's those 3 lines that you've got to get the measurements for. In this case, they're all 3, right? So my volume is equal to 3 times 3 times 3, which we've already shown would be 27. 27 what? Well, there's no units on this, so we just say cubic units. When there's no units, you just say cubic units. So, but cubes is what it means, right? But you've got to find the 3 dimensions. So when you're faced with something like this, you're like, okay, well, there's my vertex I'm going to use, and those are the 3 lines going away from it. But this one's 8, I can see that, but this one doesn't have a measurement on it. Well, you have to understand that this one here is the same as the one above it, right? It's also the same as this one. And this one does have a measurement on it, right? This 5 feet is the same as that 5 feet and the same as that 5 feet. That's the same length on that side as it is on this side, right? Otherwise it wouldn't be a prism. It wouldn't be a rectangular prism. So this one is actually 5 feet. Well, what about this blue one? Well, this blue one is how tall it is. Is there another measurement showing how tall it is? Sure enough, this one here is showing how tall it is, right? So this here and this here, they're all the same length. And this one is the same as that one, which is the same as that one, right? So when you pick your point to go from, remember that if you don't see the line have a measurement written next to it, it's going to be written somewhere else on the figure, right? It's going to be written somewhere else. So my volume is now going to be, in this case, there's only 3 numbers written, so it's fairly straightforward, but 8 times 5 times 2. Well, how do I know which one's length, which one's width, and which one's height? Well, it doesn't matter, actually, because I could do 5 times 8 times 2, or 2 times 5 times 8, and I'm still going to get the same answer because of the commutative property, right? So in this case, I'm going to do 8 times 5, which is 40, and that times 2 is 80. So 80, the units of feet, and it's cubic units. We're saying 80 cubes, 80 1-foot cubes would fit inside this shape. So that's how volume works. You have to measure and multiply together. Now there is another formula for volume, but it really is the same formula, just it's already had one piece done for you. So let's make this cube transparent here. Not a cube, rectangular prism transparent. And you can see it has 6 sides. Well, one of them is this base, right? That's the bottom bit, thing it's sitting on. Well, how would you find the area of that base? Well, to find the area of the base, you'd have to multiply the length times the width. So in this case, you'd have to multiply this side here times this side here to get the area of that base. So it would be 8 times 5, right? Which is actually what we did here first. 8 times 5, right? And then, to find the volume, you'd have to multiply it by 2, which we did. So the other formula, let's go back here. No, let's go forward. The other formula, aside from area, it's not area, volume equals length times width times height. The other formula takes the length times the width, which as we see is the area of the base, right? And it calls it area of base. So area of base, volume equals area of base times height. So in a question like that, it would have given you the number for the area of the base. It wouldn't have given you this, and it wouldn't have given you that. Instead, it would have given you 40 feet, and it's an area, so squared, 40 feet squared for the area of the base. And then, because that's already the 8 times the 5, and then you just have to times it by the height. So that's why it's the other formula. It's really, they did the length times the width for you, and you just have to times it by multiply it by the height. Now that formula is actually a better formula. And the reason why I say this formula is the best formula is because this formula will work for other prisms as well. It'll work for a prism like this, a circular prism or a cylinder, where you'd find the area of the base and you multiply it by the height and you'd get the volume of that. Or it'll work for a triangular prism like this one. Okay, that's badly drawn, but never mind. Where you'd find the area of the base and you times that by the height, and that would give you the volume of that. So it's actually a better formula because it works with other shapes as well. But for rectangular prisms, you just have to multiply length times width times height, and you get the volume. If they've already done the length times width for you, they'll give you the area of the base, and you just have to multiply that by the height to get the volume. And don't forget to put it in cubic units, right? Put that little 3 there, to show, and it goes after. You wouldn't put it here, because that would mean 80 times 80 times 80 feet, and that would be length. Now, whatever that is, that it wouldn't go there. It goes after the unit. So that's how you figure volume for rectangular prisms.